Hello and welcome to Math 200 Online Statistics at Cañada College. My name is Lapuz. In this video we will do a homework from section 11.4. It says that a certain statistics instructor participates in triathlons and an accompanying table lists times he recorded while riding bicycle for 5 laps through each of the 3-mile loop. Use a 0.05 significance level to test the claim that it takes the same time to ride each of the miles. Does one of the miles appear to have a hill? So it looks like if they're all the same, then they're all pretty even, but if one of those miles seem to take longer, then it's quite possible that there's a hill. Okay, so our null and alternative hypothesis. Our null hypothesis will have a condition of equality, and this is the only choice that has conditions of equality, and this is the only test that we really would be able to do for this particular class. So we're looking at all of the means are the same. The logical opposite of that is to say that at least one of them is different. Alright, now we're going to do our F statistic, and for this we will need to gather our data set. This particular problem says that when pasting we'll have the 3 minutes and then there's a colon that says 16, 20, 35, etc. So these will be separated. So it says here you will need to convert each minute slash second into just the seconds only. So let's keep that in mind when we open this in StatCrunch. So in StatCrunch we can see the layout. We have the minute and the second, so we're going to need to come up with 3 new variables. We'll just call it mile 1, mile 2, and mile 3. And it looks like in mile 1 the first component is a 3 minutes and 16 seconds. So 1 minute is 60, 2 minutes is 120, 3 minutes is 180. So everything will start off with 180, and then in this first one we add 16 to it. So that's 196. 180 plus 25, so I think that's 205, 203, 201, and 201. So that takes care of these first two. And now for the second mile, 180 plus 20, so that's an even 200, 203, 202, and 196, and 198. So that takes care of the second mile. Now let's take a look at the third mile. There's 3 minutes and then there's 35, so that's 180 plus 35, so that's 215. 211, and then 210, 210, and 210. So it looks like that third mile took a little bit longer than the others. Let's see if that's going to be a significant difference in measuring the mean. So this is our actual data set that we're looking for. So let's go ahead and do stats, ANOVA, analysis of variance. This is going to be a one-way table or a one-way analysis. And then they want us to compare which 3 columns are we going to compare. We need at least 3. We need 3 or more, because if we're just going to do 2 columns, then that's just comparing 2 samples, and that we did that in chapter 9. So here we're comparing 3 or more samples. So the values are going to be in the column, and then where is it going to go? Let's just leave that. This is We can ignore the other parts of this, and we can do a dot plot or a residual plot, but let's just ignore that. We can find the group means if we want, and then I think that's all we need. Okay, let's compute it. Okay, so here is the result. The main thing we want is the f-test statistic and a p-value that's associated with the f-test statistic. But for each of these things, we have the statistics for each mile. We have an average of 201 for the first one, 199 for the second one, so that's fairly close. But the last one is 210, so that looks like it makes a big jump out of there. Our f statistic is given as 24.048, which is going to be a large number. Our p-value is less than 0.0001, so that's essentially 0. So we're going to reject the null hypothesis that they're all equal. So this 211 looks like it was a big jump away from the other 2 miles that we're looking at. So let's go back and report our f-test statistic. That wasn't our f-test statistic. Let's try it again. That's 24.058. Let's just copy and paste that. Round off to 4 decimal places. So this is the 4th decimal place, 0, but there's a 9 after that, so let's round that up to 1. Our p-value is less than 0.0001, so that's essentially 0. And because our p-value is so small, we're going to reject the null hypothesis. So there's 2 possibilities here. We're going to reject the null hypothesis. There's insufficient evidence to warrant the rejection of the claim that 3 different miles have the same mean. So that is the null hypothesis, and we rejected the null hypothesis, so we cannot choose A. This is the other reject. There's sufficient evidence to warrant the rejection of the claim of the null hypothesis, so I think we'll select D for that one. Does the one of the mile appear to have a hill? So it looks like it took a little bit longer for that 3rd mile, so yes. It suggests that the 3rd and 1st mile appear to take longer. Well, I think it was just the 3rd mile that took longer. So yes, suggests that the 3rd mile appears to take longer, so it's reasonable to have a hill there. So the first, if we look at the data set again, the 1st and the 2nd mile have a mean of 201 and 199, so that's fairly close to each other. It's that 3rd mile that has a 211.2 as the mean, so that is the one that takes it away for us. So that takes longer in a 3rd mile, so there must be a hill or something that slows it down. Okay, I hope that helps.